Alright, hello everyone. This is going to be a second video on cx16os, and it's really going to be focusing on why I am using, or why I'm really only supporting 65C816. Obviously, the Commander X16 comes standard with the 65C02. There's been, part of the rationale for this video is that there's been discussions about making the 816 the standard CPU on the X16. It started out with the 816. That's why 816 X16. That's where the name came from. And I had a conversation on the X16 Discord today, and it really kind of it was really interesting, and it inspired me to make this video because I've written a lot of 816 code, especially for the programs, and I think I could give a unique perspective from the 816 side because I think I'd like it to become standard just so more people could use the OS. It's just a little self-centered, but I like programming with it. So, yeah, I want more people to have access to it. So I just want to start off with the basics. The first question is, could cx16os run on a 6502? And their answer is yes. I mean, it did. I didn't decide to pull this up, but if I go, I have 512 commits. Yeah, I probably could have done this beforehand, but if you scroll far enough down back here, I mean, a lot of work's been done, but okay, let's yeah, so I mean, you can start seeing there's some 816 works right here. So this is the first commit, maybe. Obviously, there's definitely some different stuff going on here, and you can see some of just a little bit of the changes here. But let me go back to just an old version. So for this, but let's just view the code, which is browse files. There you go. And as you can see, I mean, as you can't see, but if I pull up anything like here, the CPU is a 65C02 because it's just the default. And I mean, I'm not using any special routines. I mean, it's just running on a 65C02, and you could still do it. I mean, right here, you're transferring. Oh, that wrong way. If you're transferring, you'd see when I get to the one where you transfer X to stack, I'm not using the 16-bit values of X. There's no, there's just no 16-bit code in here. I think this is probably more evident in the helpers where, these string commands are using 8-bit code. And part of the reason I wanted to, part of the reason I wanted to go to the 816 is sort of the future. I mean, part of it was just future-proofing. I figured that eventually bloat would make the OS slower, and I didn't want, I wanted to have the 16-bit features, which would help speed stuff up. And the reason I really, I decided to cut off users to support the 816 in the way I do now is that when it's a personal project, it wasn't really, I didn't really think about other users because I didn't know if anyone else was ever going to use it. And then strings, like I can't even say this enough. I was talking about this in the Discord. Strings so much easier to work with the 816. Not having to use zero page is a lifesaver. Not that zero page is the end of the world. It's just it's a lot easier, especially when you're passing arguments. The functions you don't have to pass you can pass through one register instead of two. Like you can just pass pointers through X, which is so nice. Like just leave the accumulators 8-bit, turn on 16-bit indexing. It's pretty amazing, honestly. When you're used to programming on the 6502, it feels nice. And yeah, I mean, I'm working on an OS. There's a lot of strings, a lot more than if you're writing a game for the Commander. I don't think you really need the 16-bit modes to write games for the Commander. You could almost emulate all of the functionality, maybe except the fast memory copy between locations on the CO2, just using more instructions. And part of that also is that the programs right now only have 8K to run, so not being able to use 16-bit code saves instructions and it takes up less code space, which I thought might matter when I write more complex programs. I mean, my assembler, I don't know if it would fit in the 8K if it was running in only in 8-bit mode. I actually don't know. I mean, I could maybe try to see, but I'm not totally sure if it even wouldn't fit. And I mean, there's some comments on the 816 kind of being weird. It's sort of a thing online. Some people posting some articles, and I sort of disagree. I mean, I think it's a little over exaggerated that the X6 or the 816. Obviously, it's like supposed to be compatible with the 6502. Even has the weird like timing behaviors, but I don't think it's that hard to like deal with. Obviously, you can just, I mean, programs for the cx16os can just totally ignore the fact that you're running in 16-bit mode. The only thing it even really matters if you're trying to exit out of the program, you really like just exit instead of returning to the previous subroutine. There is no exit, so you do have to kind of change the stack pointer and then return, which is still possible in 8-bit mode because of the TCS instruction that gets added, but you couldn't do that with X, which is slight difference, but not significant enough that you couldn't just write 8-bit code for iOS. And I mean, a lot of programs still are 8-bit. I mean, Ed, if you saw what I was looking at, scrolling through those commits, Ed was added before the OS was even 16-bit. So Ed runs in 8-bit mode, always has, and it's very usable, and it still runs in 8-bit mode. I don't want to overhaul it at this point. Maybe someday, but it's definitely possible to write 8-bit programs, and same for C code. All the C programs run in 8-bit mode. Well, with certain exceptions, like some of the startup code is in 16-bit, I think. But otherwise, I mean, code is 16, or C runs in 8-bit mode. And, some people say that, tracking how big registers are is kind of a pain. You do have to use, the assembler mnemonics, but I don't think it's the end of the world. I think what you should do is just decide at the top of your program what the program should run in, just generally. And if a particular program needs this, 16-bit accumulator for a little bit, which you really don't need, you could just, do 2 add instructions, but sometimes it's useful. And admittedly, I do turn the accumulator 16-bit for a little bit and then turn it back to 8-bit. Or for some reason, if you need 8-bit index registers for whatever reason, you could also do that. But I think you can just choose one mode, and if a function needs it, use the mnemonics at the bottom of the function, just set it back to whatever it is. So, maybe A18 or A8 and then I16, whatever. That's how cx16os does it. But I'm just going to talk about some of the benefits now, or at least speed-wise, because as I talked about a little bit before, I was a little worried as I continue developing, it's going to get slower, which is, I don't think it has necessarily, but when you're using the alternate terminals, it's definitely slower. And I'm glad that I do have those are 16-bit, because it does make them faster, and that's generally slow, like especially the GUI stuff. It's hard to do a GUI on a 652. It's doable. I mean, it has been done multiple times. I'm sure someone could do it on the X16, but it helps to have 16-bit registers, which is, and any speed helps, because I taught myself, I've only been programming 6502 for however long. I'm not an expert by any means, but I'll talk about the speed. So obviously there's a lot of task switching going on. So you have to copy memory from sort of 0 page to stuff. So let me go over to. So if I go to save program process, what it does is it copies different areas inside of 0 page and also the stack to bank RAM, and then it can you can switch banks. So this is all this, but this was literally today, because I wasn't even thinking about it. You can tell I wasn't thinking about it because I have not pulled the code yet. But this was just today, so you actually see. Let's actually look at what right now. It just uses standard loops, and if you want to calculate how long these loops take, loading X with a value takes 2 cycles, and these loops, loading X with a value, or loading A with an X. Absolute X is 4 cycles. Same with storing, and then incrementing X and comparing it to ZP size 1. That takes 5 cycles, although you could decrement X and just branch on plus, which is faster. But it takes at least 12. It takes at least 13 cycles to copy byte when you're doing this. On the 816, as you'll see, it only takes 7 cycles because of 7 cycles per byte when it starts running, because of the the MVN instruction, or you could do MVP, but MVN is simpler. It just moves memory, like it's basically mem copy. as an instruction, which is pretty cool. And additionally, I mean, if you were trying to copy more than 256 bytes, I mean, it's just becomes slower because you have to either run self-modifying code, or you have to use, zero page and registers, and you got to increment the pointers, stuff like that. It becomes a pain. It's nice you can just briefly load how many bytes you want to copy, -1 because of how it works. A source, a destination, and then run the instruction, and it does just that. And I mean, if you just this copies 20 bytes, it copies 20 more bytes, it copies 10 more bytes, and then it copies half the stack. Not 20, 32, 32, 16, and 128. That's 64. It's like 100 and I think it's 200 bytes or something like that. That you're copying. So that those cycles do add up, especially when you're task switching, which is not something that happens common. You want that to be fast. And I mean, this is definitely not the only thing that happens going on during task switching. So you want the rest everything to be fast. So if I even reload it, see here what it does. So now you can just load a source pointer, a destination pointer, and how many bytes you want to copy, -1, and just run the instruction. And easier to write. It's probably easier to understand, just because it's basically a mem copy instruction, which most computers don't have really. They probably exist on x86. I shouldn't say that, but this is really simple, and I did the same thing here. I mean, what I did is basically just go like this, and it was really simple, and it worked, and I didn't really have any issues. And then at the end, you just switch back to 8-bit mode because the OS is largely 8-bit. And I mean, this saves. I didn't time it, but you're copying 200 bytes at 7 bytes a cycle. It's or it's like a 6 cycles per byte difference. I mean, it's not insignificant. And when you're doing a lot of calculation stuff, it adds up. I mean, it does matter when you're doing like a GUI, you're doing swap term, split term, which isn't really finished, isn't really functional, but like this stuff matters, and it makes programming for me at least easier. And I mean, I'm the one programming it, so I get to make all the decisions, which is not the most democratic, but I'm the only one working on it. And I think it also makes programming assembly easier for just anyone, which I think is 6502 can be a little daunting. You only have 3 registers, they're all 8 bits. There aren't even really pointers. Like these registers are really pointer registers that the 6502 doesn't normally have. Like Z80, you can use registers as pointers. 6502 you can't, but the 816 you can, which I think is something that's definitely different. And something else I wanted to look at is just kind of like string manipulation. So I'm going to go over to helper.s, and I'm just going to show you string-ln 16-bit. So what this does, I mean, basically, or what strlen does, but 16-bit makes your code, I think it just makes dealing with strings easier. So I mean, you can just be in 16-bit index mode. It already was, but I got to tell the assembler that it is. You load y0, and you just load from 0, 0 with an offset of x, and that's just loading from a pointer. That's what it's not something that you can do on really on the X16 other than loading from a 0-page pointer. But I think this is just simpler. And then you just increment. If you hit null terminator, you exit out, but otherwise you increment x and increment y, and then you branch back. I think this is pretty easy to see how I think this is simpler than having to do. Not that strlen is the most complicated routine on a 6502, but it also when you get above if you get a string above 256 bytes, you got to decide whether it's just going to loop forever, which is probably not what you want, or you got to decide that it's just going to return 0 basically. I mean, you can do other things, but then your loop gets slower. Then every string most strings aren't that size, those get slower. So there's a little bit of trade-off, and 816 means it's just pretty easy. Every string, it's just a you can treat it the same no matter what its length is. And this is helpful for me. And then you can just transfer back into A, and you get a 16-bit length. And and you probably don't even want the top length because it doesn't really matter because most strings aren't that big. But you can just you can just, you get both, which is nice. Um, and it's not like it takes longer to do that. So yeah. I mean, it's more obvious with like store and copy. I mean, this is different because or if we go to mend copy, you'd see it. But there's just different routines where it helps, and I think where it helps most is actually my ASM routine, or my assembler program called ASM. There's also a folder called ASM. I'll open it here. I mean, so much of it uses 16-bit indexing. Like, I mean, the whole thing runs in 16-bit indexes, and it makes stuff a lot easier. I mean, like make upper, you can just a lot of the string version, you just pass in X, and that's a lot easier than having to use AX. You can almost preserve A a lot of the time. You can preserve Y. It just makes like working with strings like it you can do a lot of stuff in 8-bit mode, but for me it's more convenient. It's like the subtle things that make it easier, or that make it like so much nicer to work with. Like you don't have to worry about 0-page space, because if you want to deal with strings, you gotta find somewhere to store the pointer in 0-page. With like in 16-bit indexing, you don't have to. I mean, you can just store it anywhere in mem and like just load the pointer into X or whatever you want to do. It's really just very convenient, and just I don't know. I just really like it, and I think it's been just quite like it's just been convenient. I mean, for me to just program this way, and I think it just works better. Like, I don't think it's necessarily like super hard. It sounds weird, and I'm kind of rambling now because it's hard for me to stress why I like it, but it's just been helpful. Like, just truly, like, it's nice just to have 16-bit indexing. It's just always nice to have, and it does take away some of the challenge on programming for 6502. But this is not really what that's not really what this project's about. It's about trying to make a usable kind of text-based operating system, but like a Unix-like operating system. It's obviously been done with geckos, and you can do it in 8-bit mode, but it was a challenge for me personally, and I didn't really want to take that undertaking, myself. And happily, thankfully, if you don't like the x16 and you want to program for my OS or just use my OS, you don't really have to like worry about it. Obviously, if you ever want, the assembler only works with 6502. Like, there's no 816 support in assembler, so it only can assemble 6502 basically programs, which is good because it kind of limits you. And I don't think it's necessarily like super difficult to program, those type of programs for the, in my OS, because it gives you a lot more flexibility on how a lot of stuff works. So I think you get the best of both worlds with my OS, which is why I encourage you to use it always, but it's also why I like the 816. It just gives you more flexibility, and sometimes the 6502 can be, sometimes just not non-flexible, I guess. But I'm going to encourage you to check all this stuff out. Again, part of the reason I talked about this, before I wrap up the video, I'm not sure how long, let's move to the source directory and we'll make it. But I wanted to see is how big the ASM binary is. So ASM, programs.asm/ASM. It is 5,566 bytes. And I don't know how big that is in hex, so I'll use the little Windows calculator. I love this thing. So it's about 1,500 bytes hex, which is, somewhat close to the limit. I mean, the limit is, I don't know why I don't off the top of my head, but it's this. It's 1D1000, so, 1D minus whatever, 1,500 something. You only have, about 2K left in the program. So if I wanted to add a lot more stuff, I mean, I wouldn't be able to do that, definitely in 8-bit mode. But I don't even know if it would fit. This would fit in 8-bit mode, because I think it's possible the code, expands by, say, 33%. That's not like impossible. I think it makes a lot of stuff harder to do, especially with strings. I mean, as an assembler, the whole thing's strings. You're dealing with a bunch of, it's all text files. So I think that's part of why I like, because, in a system like this, you're dealing with strings a lot more, and the 816 just makes that a lot easier. And I think that's just why I decided to support it, and it's personal, so I didn't really care if other people necessarily were able, not that people were able, but I didn't, it wasn't my biggest concern. I didn't even share this project when I decided to make that switch, however long that switch ago was. If I go back, or this was 5 months ago, this switch was made over the summer basically before I'd show this to anyone. So I hope I wanted to. Okay, let's wrap this up. So I hope this is a good explanation of why cx16os supports only the oh my god, the 65C18. Why I like this 6516, and why I think it might be beneficial for the X16 to adopt it. I think just to make, David wanted to teach people assembly with this, and I think 816 assembly is possibly more approachable than 6502 assembly. So I think that's just my thought. It's not the end of the world if I don't get my way. I'm not gonna quit and go program for some other platform. I know the Phoenix is 816, so I'm not gonna go quit and run over there or something. But it'd be nice if more people would use my software, and I think it would benefit the system, at least for the Gen 2, because the Gen 2 you're not going to be able to upgrade the CPU or downgrade it. So I think it should just have the 816. It's probably like 50 cents different when it's SMC at the quantities we're going to be David's going to be buying it at, or Kevin. So I think it might be worth it just so that 816 software is not just stuck on the Gen 1. Plus by that point all the software is going to be on the 6502, and people aren't really going to be developed for the 816 necessarily, or cut off the So that's my thoughts. Hopefully this video was interesting. Obviously, please check out the GitHub. I'll link in the description this time. I'm not sure if I did last time. But hopefully, that was enjoyable. Hopefully this contributes a little bit to the discussion on the path of the CPU we take, and then I make a fool of myself in this video. It's the first, I did script this a little bit. I think it's the first ever time I've recorded myself with a script, or really an outline. I'm flipping my paper. I don't even know if you can hear it in the mic. Move my mic a little closer, maybe you can hear it. But hopefully, some of my explanations made sense, and you got a little bit of a more perspective, because I know a lot of people have it programmed for the 816. I might be the person who's done the most program for the 816, so who knows. Hopefully, you enjoyed this again for the 5th time I'm saying this, but I'll end it here. Thanks for watching, and hopefully I'll see you again in some other video, or just on the Discord. I am Totodial Spy, if you weren't aware. So yeah, see ya.